Hi, I'm Angela. I'm a senior at Portola High School, and this is my project. So I did my project on a context-aware and geo-based mobile application to automate the notification of public health issues. Oh, that's not okay. There we go. So today for my presentation, I'll just go over a simple introduction, some of the challenges, my solution, experiments, related work, next steps, and my conclusion. So for my introduction, so I did my project targeting the problem of coronavirus. So coronaviruses are a group of RNA viruses that usually cause infections in the respiratory tracts. And so a newly identified coronavirus, SARS-CoV-2, has caused a worldwide pandemic of COVID-19. And COVID-19 specifically causes mild to moderate respiratory illnesses for most people. And for some people, COVID-19 can even be really severe and cause death. So what are some ways that we can currently stop the spread of COVID-19? So currently there's really no vaccine available. And so the only measures we can take are through social distancing and quarantine. But as schools and businesses are starting to open up, the risk of COVID-19 spreading becomes even greater. So our solution is through a mobile app that can provide a personalized real-time information on geo-based risks of potential COVID-19 exposure with context-aware features. So the challenges that we face, so the first challenge is how can we enable a personalized geo-based real-time analysis? So this could be through, the user's location and their surroundings. It could be through the data on the location and also the self-reported data of nearby people. So when one of these factors changes, the risk is recalculated and it provides a real-time analysis that is up to date. And this requires a large amount of data and the capability of big data analysis. So the second challenge is how we can integrate context-aware types of risk features to the app. So context awareness can be particularly helpful because it increases the precision of the risk by taking in the user's surroundings into account. So it requires risk adjustments for events or spots with higher risks, such as restaurants or tourist attractions and malls. And so the third challenge is how we can predict and provide the information for the areas that do not have sufficient data available. So in order to solve this issue, we can use machine learning algorithms that predict the potential risks for the areas that do not have sufficient data. So our solution is through the application VirAlert. So this study develops a context-aware and geo-based mobile application that automatically tracks an individual's surroundings and calculates the exposure risk to a public health issue, such as COVID-19. And it has three main components: the front-end user interface, the back-end server, and the database. All right, so here are some pages of my app. This is the user interface portion of it. And so here are the pages. You can see the login and the sign up pages where the users can log in and sign up to their accounts. And once the users sign into their accounts, they can view these three pages. So here are the My Locations, Nearby, and Profile pages. So in the My Locations page, users are able to view their most commonly visited locations. And actually, if you tap on those red icons, you can see the location as well as a risk at that location. And so for the Nearby page shows the nearby hotspots near the user. And so again, as you can see in the photo, if you tap on the icon, you're able to view the location, the type of location, as well as the current and the overall risk at that location. And here Here is the profile page, and users can basically indicate if they have a disease and list the diseases they have. So the second portion of the application involves the backend server. So the backend server was created using a Python Flask server. So the My Locations in nearby pages uses this Python Flask server to find nearby users, nearby hotspots, as well as retrieve the user's most visited locations and calculate a risk percentage for the user. So within this Python Flask server, there are 4 main HTTP APIs. So there's the get nearby users, get nearby hot places with all types, get most visited locations, as well as get location risk. So the first API is called get nearby users, and there are 3 parameters: the user's current latitude and longitude position, as well as a given radius to search for the nearby users. And this function really helps to find the nearby users in the area. The second API is called get nearby hot places with all types, and it also uses 3 parameters: the user's current latitude and longitude locations, as well as, again, a specified radius. The third API is called get most visited locations, and it counts the number of times the user visits each location, as well as returning the locations with the highest number of visits. And the fourth API is get location risk, which calculates the risk for each location by taking the current location from a user, and it checks for another user with the disease in a specified radius around the user. And so for every user nearby that has a disease, that risk analysis increases by 1, and the function then returns the risk for the user's current position. So the third portion of this application is the database, and this application uses a Firebase real-time database to store the user's information. So some of the information stored is the user's UID, name, age, email, and the diseases they have, as well as it logs the user's latitude and longitude positions at different timestamps. So for the experiments, I did 2 different experiments with 3 parts each. So here you can see the parts. So the first part is I tested different models for the machine learning algorithm. The second part is to test using a polynomial model. I tested it using degrees of 2, 3, 4, and 5. And the third part is to test the machine learning model with different data set features. So with like different sort of inputs. And so my machine learning model was created using 5,000 data points for each experiment. And the accuracy of each experiment was calculated using the machine learning algorithm, as well as comparing the prediction with the actual risk. So the first experiment that I did was to find a machine learning model that predicts the risks for a new geolocation that does not have available data. So for experiment 1-1, again, with the parts that I mentioned before, experiment 1-1 tests different machine learning models that were applied to the same data set. For experiment 1-2, I tested the polynomial models with different parameters. And for experiment 1-3, I tested 2 different data sets. So set 1 has 4 inputs, which is the latitude, longitude, number of hotspots, and number of events near the user. And for set 2, I tested it with 2 inputs, the number of locations and number of events near the user. And so here, as you can see, are graphs of my experiments. They show the results. And so for experiment 1-1, you can see that the random forest model actually has the highest accuracy. And for 1-2 and 1-3, there's not a huge difference. They're all around the same. So for experiment 2, I did it to find a machine learning model that predicts the risks for a user based on the most visited locations. So for experiment 2-1, I applied the same parts to it. So for experiment 2-1, I applied different machine learning models to the same data set. For experiment 2-2, I tested different polynomial model parameters, 2, 3, 4, and 5. And for experiment 2-3, I tested 2 data sets, again, with 4 inputs and with 2 inputs. And the results show that for this experiment, the logistic model actually has the highest accuracy in experiment 2-1. And again, for experiments 2-2 and 2-3, the accuracies are pretty similar for all the models tested. So some related works. So the first related work is a tracking system that tracks infectious diseases in a confined space, such as a hospital, using transmitter circuits. A second related work is an international consortium, like a group, to track COVID-19 spread based on participants' self-reported COVID symptoms. And so our application is kind of similar to this, but it takes it one step further by using personalized risk, using user-reported health data, as well as context-aware features of the user's surroundings. And a third related work is a range of online and mobile systems that track COVID-19. So an example is like Johns Hopkins CSSE dashboard, the World Health Organization dashboard, and another one called Health Map. And they basically track COVID-19 cases on maps, and they represent these trends using figures, tables, and graphs. So, sorry. So, so my next steps are basically to continue to optimize the machine learning algorithms, as well as improve the prediction accuracy. So currently, the highest accuracy is at like 50%, which is kind of bad. So to improve that, I'll basically include more users, more factors, more location data, as well as conducting more tests in order to optimize my algorithms. So in summary, the study developed a personalized mobile application to automatically track an individual's surroundings and calculate the exposure risk to a public health issue, such as COVID-19. So our application has the following features. It's personalized, it's real-time, it's geo-based, and it's context-aware. And that's what really sets it apart from other apps that do the same thing. Our application uses other users' data as well as online databases with information on COVID-19 cases to calculate a percentage revealing the user's possible risk at the location. So thank you, that's it for me. Are there any questions?
Yeah, I have a few questions. So first of all, my first question is, do you mind sharing what platform did you build the app on? Is it native Android or native iOS or cross-platform?
Oh, sure. So I built my application using Flutter. So yeah, it works for, there's a, sorry, what?
Yeah, continue.
Oh, yeah, so I built it using Flutter. And so it works for both iOS and Android. There's a version for both.
And also I have another question. So it's, how are you getting the users' position data, like getting other users' position data? Wouldn't that be a privacy concern? What kind of API is that?
Yes, this kind of is, it raises a few privacy concern issues because the application actually takes data from the user. So when the user is using the app, the application actually tracks their position as well as other things around them, their surroundings. So
they download your app, and everyone with the app can like, you're getting everyone's position who's using it.
Yeah, so when you download the app, the application takes your position. So it logs your position every like few seconds or whenever it changes. And there's a database where all the users' positions are stored. So the application basically takes all the users that are nearby you in order to find if there's anyone with a disease.
And also, are you able to put in if you were tested positive or negative for COVID-19? Are you supposed to put that in the app?
Yeah, so there's a portion on the profile page where users are able to indicate if they have a disease and also list what they have.
Okay, thank you.
Angela, do you want to show the demo of your app to make everything more clear?
Yeah, I was going to do that, but it's taken a while to load. I think it's working out though. So yeah, so here's my app. Something happened to it. Wait, my buttons disappeared. Yeah, so here's my login page. Typically there are 2 buttons here that allows you to log in and another one that takes you to a sign up page. I don't know where they went. Let me go hide and go seek real quick. All right, this is gonna take a while. So while it's running, how are you guys? How is everyone?
I think we can, if anyone has questions, can ask Angela maybe during, while she tries to find.
Okay, so what really inspired you to create this app?
Yeah, so I was inspired to create this app because, I mean, obviously COVID-19 was pretty scary. When we went back, like when schools and businesses started to open up again, it was pretty scary for me. I didn't want to get COVID, so I decided to create an app that could create a risk analysis so it could warn me if maybe I could get COVID.
Cool, and we have a question in the chat from Justin. When did you start making it?
Okay, so I started making the app in June, July, August. So it took me maybe like 2 months to make it. All right, it's working now. The buttons are screwed up, so maybe ignore that, but they work. So here is the login page. So as you can see, if you click the sign up button, it takes you to a sign up page where users can input their name, their age, their email, their password, and they can create a new account. I actually have a demo account created, so I'm just gonna go ahead and log in.
Is this already on the App Store, or are you planning to get it on the App Store?
Oh, very good question. So I tried to get it on the App Store,
And you can't.
but yeah, so unfortunately, Apple regulates their apps related to COVID because they don't want to spread any potential misinformation. So in order to publish a COVID-related app on the App Store, you have to have be like a organization.
Yeah, government, I think.
Yeah, you have to be a government organization.
I'm very sorry for that. I hope you get it on the Google Play Store, though.
Yeah. Oh, I think it did get on the Google Play Store, so that's good. All right.
Is this project just an app, or like is there a website too?
So far, it's just an app. I can create a website, but that's going to take more work. All right, so here, as you can see, I logged into the app. This is the My Locations page. It shows my most commonly visited locations. So I'm here in Irvine, and I also went to San Diego. Yeah, so if you click on each icon, it actually takes you to the location and it shows you the risk at that location. So now I'm clicking onto the nearby page and it's going to show me the list of nearby locations around me. And at each location, it shows you a risk. So if I'm going to click right here on this icon, it's going to show me that this is a store. It's called We Play Music, apparently. So right now the risk there is 0, but the overall risk there is a 7. And I can go ahead and click on other locations as well. Yeah, so that's a school, there's a risk, and there's an overall risk. And so now if I click my profile, here you can see that this is my profile. I can click this on or off button to show that I have diseases. And I can also list the diseases I have. So I could write like COVID, anthrax, or other diseases. And I can save. Oops. All right, well, it says it's saved user here, so it should be updating that list there, but it's not right now. But it did in the database. So that's how users can show that they have diseases. So that's pretty much how my app works.
We have someone who asked previously, what is the name of the app? And how do I download it?
Oh, okay. So my name, or the app's name, is called Viral. Can you see it at the top there? It says Viral at the top, like right there. And I don't think you can download it right now, unfortunately, on the App Store, but it is available on the Google Play Store. Yeah. Maybe if you search Viral, you'll be able to download it.
I put the link to the Google Play download in the chat. So if you guys are interested, you can go download her app.
Great, thank you. Oh, I see the question, how do I prevent false information? Okay, so that's a very good question. My application does not, it's not a definite risk. It doesn't tell you like, if there's a 3 here, then you have a low risk of getting COVID. And if there's a 9 there, then you're definitely gonna get COVID. But it just shows you that, you know, based on the location you are at, what's your potential risk to potential exposure in the area. How do I prevent false information? It just gives a warning. It doesn't really like tell you how much you're gonna get it.
So, what are some future improvements you would like to make?
Good question. So in the future, I would definitely like to improve my app's accuracy. Currently, the highest accuracy is around 50%, and the other accuracies are around 30%, which is pretty bad. I definitely like to improve it by using more databases to sort of train my machine learning algorithm more. The accuracy percentage could be at least 70 or 80%.
Wait, so I actually want to know, what does the percent really mean? It's like me tossing a coin and probability is 50%, or like how accurate is 50%?
Yeah, so I got the accuracy by sort of using the machine learning model to predict the risk at the area, and I compared it to the actual risk at the area, and so that's a 50%. That's where it comes from.
And how do you find out the actual risk? Is it from like an official source?
So I have an algorithm that sort of calculates the risk, So I basically took a location with a known risk, and I used that exact location to predict the risk using my machine learning model. And so I generate both an actual risk and a predicted risk using the model, and I compare those two.
Okay, so let's say in a couple years later, COVID has died down. So how do you think that would affect your app?
Good question. So in a couple of years, when COVID does die down, the app can still provide a risk based on other diseases that act similar to COVID. So if there are diseases that spread easily with large groups of people or large events, or with a crowd of large people, this app can definitely still provide a risk analysis for those diseases. Mm-hmm.
Okay.
Is this your first time making an app?
I had some experience creating apps before this, but that app was pretty basic. It's just a chat app. So, yeah.
So do you plan on making more apps in the future?
Yeah, I want to get into comp sci. Apps are pretty fun.
You're planning on to getting a native iOS?
Sorry, what was that?
Are you planning? Because I think you say you like making apps, so maybe native iOS is a good option to consider.
Oh, maybe I will. Sorry, I'm pretty new to comp sci, so I don't know much, but I'll definitely look into that.
Xcode is cool.
So before you guys go, please follow us on Twitter at Coding Minds Academy and Facebook at Coding Minds _Minds. Oh wait, at Coding _Minds. So that's it for tonight's Coding Minds project presentation. Great job, Angela, on this project. Tune in next week for another Coding Minds conference, and we'll see you then. We want to thank you on behalf of Coding Minds, and have a great evening, everyone. Thank you, guys.
Thank you.
Thank you. Good night.
Thank you.